Hello viewers and welcome to this lesson. We are going to talk about matrix, that is matrices, under the subtopic determinant and inverse of a matrix. Our guiding objectives: 1. Evaluating determinant of a 2 by 2 matrix. 2. Using inverse matrix to solve equations. So when you multiply two matrices together in the order AB or BA, the result is an identity matrix. And so for matrices A and B, they will be inverse of the other. So just to talk about identity of a matrix, or rather identity matrix, it is given by matrix 1 0 0 1, and it is a matrix that behaves like number 1 because whenever you multiply, the result has got no change. We get the identity matrix when we multiply a matrix and its inverse. To show two matrices are inverses, then we can multiply A, B. That is, AB means it is the product of two matrices, matrix A and matrix B. So whereby matrix A is either the inverse of B or B is the inverse of A. So that is why we have AB is equal to inverse. That means we multiply matrix A times matrix B, you get an inverse. And for that case, A is a matrix, B is its inverse, for you to get the identity matrix. On the other part, BA, you are alternating. So it is B is either the matrix or B is the identity. You multiply by its matrix. No, I mean B is the inverse matrix of A. So when you multiply that, you get the identity matrix. So what I'm saying can be made easy by A times A inverse is equal to identity, or A inverse times A is equal to identity, whereby A inverse is the inverse of A, shown there. Now let's now look at an example to be able to sink the point home. Show that B is the multiplicative inverse of A. So we have two matrices. We have matrix A and matrix B. Matrix A 3 negative 1 7 1, matrix B 0.1 0.1, negative 0.7 and 0.3. So to show that B is the multiplicative inverse of A, then it means we need to go back. We have just said when we have AB is equal to inverse, is equal to identity, I mean. So that means A, when we have AB, A is a matrix, B is its inverse. So in this case, if you want to find AB, because we know that AB, when we multiply together, we are going to get identity. So when we get identity, then that means B is the inverse matrix. So AB is equal to I, that is the identity. Therefore, B is the inverse of A, and A is the inverse of B. So that means when we multiply A and B, we get an identity matrix, and that means that either B is the inverse of A. So we just prove using AB is equal to I. And if you get an identity, then that means B was the inverse, because it can only be an inverse when it is giving us an identity when we multiply it with its original matrix. So BA when we do the other way around, that is BA is equal to I, we still get the same thing. That is the identity 1001. Show that the matrices are multiplicative inverses. So this one, we have a matrix A and matrix B. We know that either AB will give us identity or BA will give us identity matrix. So identity matrix is the one which exists in 1001. So by multiplying BA, you'll get identity matrix. And now let's look at the determinant of a 2 by 2 matrix. So we can say the determinant is used to tell us if an inverse exists. I mean, if the determinant is not equal to 0, an inverse exists. But if a determinant is equal to 0, there is no inverse in that case. So to calculate a determinant, we have matrix A, B, C, or rather the matrix of A given by the elements A, B, C, and D. So to get the determinant of A, abbreviated as det of A, then we multiply along the diagonals. So we have AD minus BC. That will give us the expression, or rather equation, to find the determinant. Now, using real examples, evaluate the determinant of the matrix. So we have the matrix 7, 8, negative 5, negative 9. So the determinant, of course, we are going to multiply along the diagonal. And so we will have the main diagonal, which is 7 and negative 9, minus the product in the other diagonal, that is of elements 8 and negative 5. So that means we have 7 into negative 9 minus 8 into negative 5. When you do that and subtract, you get negative 23. And now this means that the determinant is not equal to 0, meaning the inverse exists. So the matrix has got its inverse. Number 2, evaluate the determinant of the matrix 4, 2, 4, 2. So to get the determinant, we'll multiply the elements in the main diagonal minus the elements in the other diagonal, so that we get the difference. So we have 4 into 2 minus 4 into 2, you get 0. In this case, if a determinant is equal to 0, then it means the inverse is not there. So let's now look at the determinant and inverse of a 2 by 2 matrix. Now, how do you know if a matrix has an inverse and what that inverse is? So of course, I have A inverse. A inverse can be given by, if you want to find the inverse of a certain matrix, it will be given by 1 over determinant times the transpose. Transpose is interchanging the elements in the main diagonal and reversing the signs in the other diagonal. That is what transpose means. So if I have, for example, determine whether the matrix has an inverse. If an inverse exists, find it. So matrix is given, the matrix we have here is matrix M, given by elements negative 2, 2, 5, negative 4. So first, we are going to find the determinant of matrix M. And so that is, we get negative 2 times negative 4, then minus 2 times 5. Because if you are following keenly on this lesson, then you know how to find the determinant of a matrix. So determinant of M is -2. That means the inverse exists. And now that the inverse exists, we want to find that inverse. Of course, to find the inverse of a matrix, we are going to follow certain procedures, which is 1 over determinant times the transpose. Now we want now to find, because now we have the determinant, we just need to put 1 over that determinant. And the other thing is on the transpose, which I want to clarify. So on the transpose, what you see in this shown by this arrow is the other diagonal. So we are going to, you can see that the signs are positive because we have +2 and +5. So when you want to find the transpose, then we are going to reverse their signs. So that sign is going to be -2 and -5. So we have -2, -5. And now we come back to the main diagonal, what you see there. We are going to change their position. We are going to change their position so that -2 will assume the position of -4 and -4 will assume the position of -2. So we will have -4, -2, -5, -2. That is our transpose. And now we come back, we use the equation to find the inverse. And now the inverse of M, that is M inverse, will be given as 1 over determinant, that is 1 over -2, multiplied by that transpose. And so we simplify our work to get that the matrix, the inverse of our matrix, that is M inverse, is 2.51. Number 2, determine whether the matrix has an inverse, and if it has, find it. So the matrix in this case is 2, 4, 1, 3. So we do the same. We find the determinant, which is 2, after which to find the inverse, then we have 1 over determinant times the transpose. So you know how to find the transpose, so it will be 1 over 2 times the transpose, and then you simplify your work, it will be 1.5 to -0.51. Okay, you can also leave your answer as 1, 2 into bracket 3, -4, -1, 2. It's all the same.